Did Einstein prove Tesla wrong? Or are we still missing something about the fabric of reality? This isn't just a debate between two scientific giants. It's a window into two fundamentally different views of the universe. In this video, we explore the clash between Nikola Tesla's belief in a dynamic ether and Albert Einstein's revolutionary theory of spacetime. From the 19th century to modern quantum physics, the question still lingers: what is space really made of? The concept of ether dates back to ancient Greece, where philosophers like Aristotle imagined a fifth element, ether, permeating the heavens. By the 19th century, ether had become a serious scientific hypothesis. As scientists discovered that light behaved like a wave, they assumed it needed a medium to travel through, just like sound through air or ripples on water. This medium was called the luminiferous ether. James Clerk Maxwell's equations described how electric and magnetic fields oscillate to create electromagnetic waves, including light. But what carried these waves through empty space? Ether seemed like the obvious answer. The ether was imagined as invisible, undetectable, massless, and rigid enough to transmit light at incredible speeds, yet subtle enough not to slow down planets or interfere with motion. But this convenient solution had a problem. No one could detect it. In 1887, Albert Michelson and Edward Morley conducted an experiment to detect Earth's movement through the ether. They used an interferometer to measure differences in the speed of light as Earth moved through space. If ether existed, light traveling against the ether should move slower than light traveling with it. But the result was shocking. No difference. Light always traveled at the same speed. This null result was one of the biggest experimental failures in physics, yet it paved the way for a new understanding of space itself. In 1905, Albert Einstein published his special theory of relativity. He proposed that the speed of light is constant in all reference frames, and that space and time are not separate entities, but part of a unified four-dimensional fabric spacetime. His 1915 general theory of relativity went even further. Gravity, Einstein said, isn't a force acting through space, but the result of mass-bending spacetime. Objects follow curved paths not because they're pulled, but because the fabric they move through is distorted. Einstein removed the need for ether entirely. There was no background medium. Spacetime was the medium, and it was flexible, reactive, and deeply tied to mass and energy. His ideas were confirmed again and again. Mercury's orbit, gravitational lensing, time dilation observed in GPS satellites. Einstein's spacetime worked, mathematically, experimentally, and practically. Nikola Tesla, however, wasn't impressed. While Einstein revolutionized theoretical physics, Tesla focused on experimental science. He believed in a physical, dynamic ether that filled all space and carried energy. To Tesla, the ether was essential for understanding gravity, electromagnetism, and even the human mind. He envisioned a universe of frequencies, vibrations, and resonance, interconnected through a medium no one could see. Tesla said, "All perceptible matter comes from a primary substance, or tenuity beyond conception, filling all space, the akasha, or luminiferous ether." He believed Einstein's theories were elegant, but disconnected from reality. Tesla claimed that relativity distorted the true nature of space and time. He once said, "I hold that space cannot be curved, for the simple reason that it can have no properties." Tesla's view was intuitive, rooted in natural observation and his belief in universal energy. He wasn't alone. Other scientists of the time also struggled with abandoning the ether altogether. While Einstein's spacetime remains a cornerstone of modern physics, the idea of a vacuum being truly empty has been challenged by quantum mechanics. Quantum field theory reveals that space is filled with fluctuating quantum fields. Even in a vacuum, virtual particles constantly pop in and out of existence. This so-called quantum vacuum isn't the same as Tesla's ether, but it's far from empty. Then there's the Higgs field, which permeates all space and gives particles their mass, or dark energy, the mysterious force causing the expansion of the universe to accelerate. These ideas hint that space might be more filled than we thought. Some physicists have revisited ether-like concepts. In emergent gravity, for example, space-time itself could be a low-energy manifestation of more fundamental quantum interactions. In this light, Tesla's vision of a dynamic, energy-filled medium doesn't seem quite so far-fetched. Tesla and Einstein embodied two poles of scientific inquiry. Tesla trusted intuition, direct experimentation, and the holistic harmony of nature. Einstein trusted the power of abstract reasoning and mathematical consistency. Tesla was a pioneer in electricity, wireless transmission, and energy systems. Einstein redefined gravity, light, and the structure of the cosmos. They had very different tools and goals, but both tried to answer the same question: what is the true nature of reality? Einstein's legacy is firmly rooted in modern physics. Tesla's legacy, while more controversial scientifically, continues to influence engineers, inventors, and seekers of hidden truths. So, is space just warped geometry, as Einstein said? Or is it an ocean of unseen energy, as Tesla believed? Modern science leans toward Einstein, but the more we study quantum fields, dark energy, and consciousness, the more questions arise. Could the ether return under a new name? Or are we slowly discovering it already, hidden in the vacuum fields and quantum foam? Tesla and Einstein remind us that science is not static. It evolves, sometimes in circles, sometimes in leaps. What was discarded yesterday may inspire discovery tomorrow. If the universe is a symphony, Einstein gave us the sheet music, but Tesla might have been listening to the music itself. Infinite narratives. Subscribe for more scientifically grounded space stories that connect physics with imagination. See you soon.